Hi, welcome to our next level 1 tables, equations and graphs video. We're going to continue talking linear functions and we're going to talk about negative gradients. We know the gradient of a line is a number and that number determines how steep the line is. The larger the number, the steeper the line. The gradient is equal to rise over run. Rise is what we move up and down and the run is what we move left and right. So gradient is equal to rise over run. Right, here's our example 1 from our last video. This line has a gradient of 3/5. So let's pick 2 points on the grid, and to get from the left-hand point to the right-hand point, we must rise up 3 squares and run across 5 squares. All right, here's example 2. This line has a gradient of -1/8. So here's 2 points on the grid, and we're going to get from the left-hand point to the right-hand point. To do that, we must rise down 1 square and run across 8 squares. So rising down 1 and running across 8. Right, I've drawn these 2 graphs on the same grid. We have our gradient of 3/5 and our gradient of -1/8. We can have what we call positive and negative gradients. Positive gradient is kind of like it looks like it's going uphill as we look from the left and we move to the right. A negative gradient is like the line is coming downhill as we move from the left-hand side of the screen to the right-hand side. So positive gradient goes up, negative gradient goes down. Right, a couple of things that it's important to remember as we progress into this journey. A positive number divide positive makes positive, and a negative number divide negative also makes positive. So if they are the same, they turn out to be positive. But if they're different, if one's negative and one's positive, then the answer is negative. Now let's look at this example, -1/8. So it's a rise of -1 and a run of 8. Well, I could have written it as 1/-8. It's the same thing because one of them's positive and one of them's negative, it's still going to be negative. Or some people like to just put the negative sign out the front because they know a positive and a negative make a negative, and they put it out the front and make it -1/8. Those 3 things are written this differently, but they mean the same thing. What about if the rise and the run was both negative, -1/8? Well, hopefully you can remember that a negative divided by a negative makes positive. So we'll just write it as 1/8, which would be a positive gradient. All right, let's move on to a couple of more tricky examples. Example 3, this line has a gradient of -3. Now, first of all, we need to write -3 as a fraction, so -3/1, because -3 divided by 1 is still -3. Any whole number can be put over 1 and still be the same number. If I find 2 points on the grid, and to get from the left-hand side to the right-hand side, I must rise down 3 and run across 1. Sounds a bit weird to rise down 3. I know when we talk about rise, we think about going up, but a negative rise means to go down 3 and run across 1 square. So remember, anytime you see a gradient that's a whole number, even if it's negative, we put it over 1 to turn it into a fraction, rise over run. All right, what about this example? This line has a gradient of -1.2. Well, it's a decimal. We had a problem like this last video, and here's how we're going to do it. We're going to write it as -1.2/1, but instead of doubling each, I'm going to be tricky, and I'm going to go times the top by 10 to get to -12, and times the bottom by 10 to get to 10. And -12/10 can simplify down to -6/5. And now I know that this line rises down 6 and runs across 5. Right, last example. How do we draw a line with a gradient of -1? Well, that's easy. We put it over 1 because any whole number has to be put over 1, -1/1, and that just tells us to start somewhere, to rise down 1, and to run across 1, and this is what the gradient of -1 would look like. Thanks.